In this video, we're going to talk about scatterplots. So we're going to make a scatterplot, we're going to draw a line for a scatterplot, and then we're going to interpret the slope and y-intercept and use the line to make predictions. So to do that, we need to start with a set of data. All right, so here we've got some ages and heights for various children between the ages of 2 and 9. We're going to go ahead and put this on a scatter plot. Think about what the independent and dependent variables would be. So we're setting up a graph. We know we're just going to need a 1-quadrant graph because all of our numbers are positive. The age is going to determine the height. We're not trying to use height to predict age. We're going to try and use age to predict height. So we're going to put age here and height here. Okay. So now to make a scatter plot, we're going to plot the points. Okay. So I changed the 4 to be 40, not 50. That was a typo on my part. So the graph looks something like this. You can see we can tell we were looking at multiple different children because we have a 2-year-old who's 30 inches and also a 2-year-old that's 35 inches, right? That's clearly not all the same kid. From here, we are going to model this with a line. So lines are very easy to work with in math. So even when things might have a slight curve, we usually model them with lines. And to do that, what we want to do is we want to first and foremost get the slope right. So we want to kind of look and see, is this growing at the right rate? And then once we have it growing at the right rate, we want to have roughly an even number of points above and below. So that looks pretty good to me. Maybe a little lower. How about that? Looks good. Okay. Ish. Extend it a little bit further. Okay. So now this line is like a predicting line. So this is a line that's kind of showing what's typical for this specific group of children. They might be taller than average or shorter than average. I don't really know. And it's something that we could use to make predictions about a child. If you didn't know anything about them other than their age, you could use this line to kind of guess approximately where they might be. So the first thing we might need to do is write an equation. This is a line, so our equation is going to be in y equals mx plus b format. And when we're doing statistics and we're making predictions, we use, instead of doing y, we do y hat. The y hat means predicted y, or predicted output. So in order to do a line, we're going to have to make a slope and a y-intercept. So the y-intercept is going to be that b value. Looking at my graph, it looks like the b value is at approximately, maybe let's say 26, looks like. And then the slope, we're going to have to draw a slope triangle. So we want to pick some spots on the graph where the line goes through the lattice points. So for mine, it goes through right there and there, right on that point. So you'll notice one of those points was an actual point. The other one was not. It doesn't have to be an actual point. Once you've got a couple spots where it goes through nicely, we can use that to find our slope. So here it's going from 1 to 7. So that's a growth of 6. And it's going from 30 up to 50. So that's 20. So I'm going to do 20 divided by 6 because slope is always the change in y divided by the change in x. And we can see what decimal that gives us. And that gives me approximately 3.3 repeating. Or I guess it gives me exactly 3.3 repeating, but these are approximate points. So everything here is approximate. Okay, so now we can write our equation, y hat, because that's just symbolic. It's just showing that it's a predicted y, is 3.3 repeating x plus 26. Now, you might be asked to interpret what that slope means and what that y-intercept means. So we could write those as a sentence. So we could say that the typical child grows 3.3 inches per year. Because that's what that number means in context. It's a rate. It's happening every year that it's growing. And then that 26, that one's a little bit weird, but that would mean that the typical baby is 26 inches at birth, which is not true. That's a very, very long baby, 26 inches at birth. Now, if we think about it, none of my data started before 2. So to use my line to make predictions about birth weight, like babies grow really, really, really fast, right? So like if we actually had data for babies, it would probably go like, pew, right? It probably like, well, maybe not all the way down to 15, but it would have like a little curve at the end because the beginning of a child's life, they grow a lot faster than they do at other times. So doesn't really make sense to use our y-intercept as the length of a baby at birth, but that is what it means according to the graph. So if we were asked to interpret it in context, we would say what it is, and then we would say it's like not necessarily accurate. Not accurate. Babies grow faster. If we had some data that was right around 0, then we would trust that as being accurate because we have some data there to back it up, but we don't, so we're not going to. Not accurate, babies grow faster. Okay, the other thing you might have to do other than interpreting the y-intercept and the slope is that you might be asked to make a prediction. So we'll notice that I don't have any 8-year-olds in my data set. How tall is a typical 8-year-old for this data set? So you could look at the graph and you could go up and you could be like, looks like, I don't know, 52 or something. If you wanted to get more precise, you would use the equation. So you would say that 8 is the x value because that's the years. So y hat equals 3.3 repeating times 8 plus 26. And you would do that math. So that would give us 26.6 repeating plus 26 is 52.6. 52.6 repeating. So that would mean that the typical 8-year-old is about 53-ish inches tall. Okay. And you could also use the line to predict how old someone is when they reach a certain height. So about how tall is someone who's 30 inches tall. If I look at the graph, I can go over and I can see that they're about 1 year old, maybe. Once again, our data may not be accurate around the 1 year range, but you could do that. To do that, you would plug in 30 for y and then solve for what x had been. So you can just solve the other way around. All right. Now, sometimes you might be asked to make a prediction that doesn't make sense at all. So like if I asked you to predict how tall is a 100-year-old, you could do the math. And the math tells us that they are 359 inches tall. So this is a classic example of trying to apply data outside of its scope, right? So this is data that only makes sense for kids. It does not make sense for adults. So we would say that it's technically outside the domain of the data. All right. For your practice problem, you do not need to copy down this graph, but I'm giving it to you here. You can like roughly sketch it if you'd like. I am going to ask you to interpret the slope and y-intercept. Y-intercept. So you've been given an equation right here. You've been given a graph. You've been told that we're talking about the weight of something and the price of something. If you want to make up what we're weighing, you can, or you can just say it in general. So interpret the slope and y-intercept, please, given the numbers and the equation. Good luck.